All right, so my name is Ryan Leonard. I am a cloud architect and data scientist at Eagle Dream Technologies. I've actually built, along with Dustin, several of the data lakes that we've been talking about for the last couple hours. And one of the core reasons we build these data lakes, as Dustin alluded to, is for AI/ML. I love this stuff. I've been working in it in AWS. I'm excited to get into an overview of it. So, and just going back to the goals of the workshop, now we're at sort of the third goal, how to start building, training, and deploying machine learning models. Like I said before, introduction to machine learning. This is basically an overview on sort of talking about how machine learning is done in the past and how we're doing it in AWS, specifically focusing on a service called Amazon Sagemaker, but we'll be going into that in detail. So I'm just going to continue on here. I'm going to start out with a poll. It's just basically asking your experience with machine learning, seeing just for me to gauge the audience, see if we have a good variation of audience members. And like I said, throughout this presentation, feel free to put a question in the chat. I'll be happy to take a break and talk about anything you guys want to talk about. All right, so it seems like we've gotten to 81%. I understand some concepts, but have no experience as a practitioner. That's a good place to be for this discussion. So I'm going to go ahead and carry on.
Nobody considered themselves an expert?
Yeah, I'm surprised by that. I thought there at least.
I feel like it's hard for anybody to self-describe themselves as an expert.
Yeah, I get it. But Carnegie Mellon's down there in Pittsburgh, so there has to be a few around. Okay, so this is sort of the core machine learning stack on AWS. There's 3 layers. The bottom layer would be for the experts if there were any, but I guess there's not. So that this is where you would have to be manually building, training, deploying, testing, all this stuff on your models. You'd be running these traditional sort of platforms, TensorFlow, MXNet, etc., on EC2s, on Greengrass, on other things of that nature. Then we go up to the second layer, which is what we're going to be talking a lot about today, which is Amazon SageMaker. It's sort of the middle layer. You're still training models, but a lot of this whole process is streamlined, unlike what used to be done. And then on the top level, we have things like these out-of-the-box sort of API-based services like recognition, Poly. Like Poly, for example, does text-to-speech. Recognition takes video and images, and essentially you could do things like, what's in this image? It'll tell you a car is in this image, a tree's in this image, or, do these people's faces match up against faces in this registry? Tell you things of that nature.
Hey, Ryan.
Yeah.
This is a good time to point out also that everything across that top bar, we're going to be distributing the details on those out-of-the-box ML tools as a separate handout so that if something that's useful to anyone in particular, the fine details will be available to people. Everything that says like recognition image, recognition video, everything in that top stripe will go out as a separate handout so people know what pre-built ML is ready for them right now.
Yeah, and these pre-built packages are really there. You don't have to be a machine learning practitioner at all. You really just have to be a developer. They're there for when you're building an application. There's a common problem. Everything up here has been designed to solve common problems. Like, for example, let's say you have a bunch of MP3s and it's people speaking, and you need all of that speech saved as text to do text analytics over it. Poly would be a great service for that. Let's say you have PDF files and you want to get the text out of that, or if you have videos and you want to get the text out of that, Textract. So these are really for developers. It's to help developers solve common problems without having to get into the details of AI/ML too much. Like I said, SageMaker is going to be our focus. SageMaker sort of streamlines the process of AI/ML, and we're going to be going over the whole machine learning lifecycle throughout this presentation. So we'll be talking about sort of how things were done in the past and how AWS makes all these things just a little bit easier. So I will move on. Is there any questions on this slide? This is a big one. That's why we created that secondary document for this one. So this is the machine learning lifecycle. It starts out with collecting and labeling data, cleaning the data up, which is a little bit of that ETL that Dustin talked about with Glue, developing a model, then training that model, evaluating it, oftentimes that's a recursive loop. You evaluate your model, find out it's no good, going back to the training portion. Then you have to deploy the model. Yeah, so back what I was saying, this is the machine learning lifecycle. And in the past, machine learning was just really difficult for a lot of organizations. Not only did you have to deal with cleaning the data yourself, you had to figure out what algorithms you were going to use, train your model, make sure you have enough resources, and compute power to even train your model, evaluate it, do all the hyperparameter tuning yourself, then deploy it. Then even after you deploy it, make sure that it still scales. Make sure that the traffic coming into your model isn't too much for the hardware that you have. That essentially goes away with Sagemaker. Sagemaker manages a lot of the aspects of the machine learning process. We'll go into the details of that. Hyperparameter tuning, scaling your inference models. So when your applications are using them, they don't go down. Also, all sorts of things like that. So I'm going to go on to one more poll here for now. It's going to ask about people's past difficulties or what's been the most challenging part of the machine learning lifecycle for them. I think I know the answer, but I just want to see if I get validated. Failed to launch polling error. What's going on here?
It's up.
Is it? Okay.
Yeah, I can see some answers coming in. Maybe like 20 more seconds. Thanks, guys.
I still can't see the answers.
You may not see the results anymore because you turned over to Courtney.
Right. Okay. Okay, that makes sense.
Alrighty, I'm gonna share the results. Looks like
Awesome.
data
Thank you.
collection and preparation.
Yeah, that's exactly what I was hoping people would say. Perfect. Okay, good. Then we can go forward. So Amazon Sagemaker, back to the core piece of this presentation. This is the traditional life cycle that we've been talking about, but broken down into the components of Sagemaker that would help in each of the pieces of the life cycle. For example, ground truth, which we'll talk about, notebooks, training, inference. Ground truth is going to help us collect and label data. Our notebooks are going to do some additional ETL. Just a side note here, even when you do ETL with Glue and you get rid of sort of the data inconsistencies and the problems with the data, it's still not always in a way that's ready to be used in training a machine learning model. So there's often an additional step included to clean, format, and transform. Notebooks are used to develop and train the models. The training is another component of Sagemaker. I don't want anybody to get confused. Notebooks and training can both be used to train models. I'm actually going to show you how to do it in the demo using the notebooks. And the training component also helps evaluate the model. Then the inference component of Sagemaker helps you deploy and scale and manage the models. And I will be showing in the console after this presentation each of these components directly in the Sagemaker console. All right, we're just going to start off with ground truth, get a little bit more in depth into these core components. Okay, so how ground truth works is it essentially makes the whole process of labeling your data a whole lot easier. Based on the responses from the first poll, it seems like some people have at least a basic understanding of how machine learning works. But for the people who don't, I'll talk a little bit about supervised versus unsupervised learning. Supervised learning essentially requires your data to be labeled because it's going to be used to make predictions based off the data that you feed it in training. And that data has to be labeled. So if, let's say you're trying to build a model that is going to predict whether an image is of a cat or a dog, you need to train that model with images of cats or dogs. And each of those images has to be labeled as a cat or a dog so the model knows what it's looking at. So what Amazon Sagemaker Ground Truth does essentially speeds up that labeling process, as opposed to unsupervised learning where you're really sort of the goal is more to find trends and patterns in your data to do things like clustering, so to speak. So how Ground Truth works essentially, you have your raw data in S3 unlabeled. You initially train some of that data by hand. Humans have to do it. Now we'll go into which humans are doing it. That's in a later slide. An active learning model actually trains itself with the label data. So you're labeling data by hand. That active learning model is seeing what you're doing. And then as you train more and more by hand, it's picking up on how to label the data itself. And this goes through a little bit of an iterative process when it's not too sure, because it goes off of confidence intervals. When it's not sure what to do, it's going to kick that record back to you, and you're going to label it, and then that's just going to make that active process better and better over time. And what this does essentially is reduces the time and cost of labeling data sets. It's going to be up to 70% cheaper, because when you don't have to hire humans to do it, you save money and time, which is great. So that really goes towards the component of the machine learning lifecycle that people tend to think is the most time consuming, which is labeling data and coming up with a data set that can be used for supervised learning problems. So that is the beginning of ground truth. Next slide, please, Courtney, unless there's any questions. So this slide is an example of the console for Sagemaker ground truth. What this is showing is you have the 3 labels on the right. You have cat, dog, bird, and it's asking, okay, which one of these is in the image? Or more, sorry, I misspoke. Please put a box around the animal in the image. Then you're going to submit it, and it's going to aid in the process of active learning. So there's a little bit of this type of process, especially for images. Now, I don't want people to think that ground truth can only be used on images, because it can be used on really any kind of data, including text and unstructured data that you'd like. This is just an image example. Okay, so when we talk about ground truth, we talk about a human component to labeling the data by hand. There's a few options on how to do this. You could ultimately do your private labeling with your own workforce. You could, pay people in your own organization to do this. Oftentimes not the cheapest solution. You can work with third-party vendors that are shown there. They can take on that piece, or you can use what's called Amazon Mechanical Turk. And a Mechanical Turk is essentially a workforce that you can rent out from Amazon. They're people. It's not a compute service. They're actually humans that will take on these jobs for you at quite a reasonable price. So that's probably the cheapest solution out of any of these. And they'll pick up that grunt work of helping ground truth label your data. Next slide. Okay, so Sagemaker notebooks. All Sagemaker, this is just the introductory slide. We're going to go on to Sagemaker notebooks now. So all Sagemaker notebooks really are Jupyter notebooks that are being hosted within the AWS Sagemaker environment. These notebooks have multiple built-in kernels. They can run Python, they can run R, they can run many of the popular machine learning frameworks like TensorFlow, for example. You can also install your own kernels. They have Git integration, and they support Jupyter Lab. The really cool thing, and you're going to see, because I'm using one of them, is the sample notebooks that they have for Sagemaker. So if you want to just play around with the algorithms, they have quite a number of sample notebooks where if you want to try a specific algorithm, it'll walk you through step by step how to do it. You can just click through, watch it happen in action, and it's a really good learning resource. All right, so going into that, notebooks, like I said before, just to close up that section, they can be used for training and deploying your models, as well as doing any other ETL. I mean, essentially they're just code writing environments. So if you want to lump all of your ETL process into a Sagemaker notebook, you could do that as well if you'd like. But one of the things I do is training. So as I mentioned before, you can start your training jobs directly through the Sagemaker notebook or right in the console. There's no difference. What you do is essentially you tell it what kind of hardware you'd like to use, depending on the job and the amount of data. You're going to want to choose the appropriate instance type, EC2 instance type, more data, bigger instance, different kind of instance. Then you're going to want to define some hyperparameters, and all a hyperparameter is a value that determines exactly how an algorithm is going to run. So they all have different hyperparameters depending on the algorithm. And then you have to put an output location where you want your trained model to go when it's finished with, and then select the particular algorithm that you're going to be using. And you can do this via the SDK and notebooks or directly in the console, like I said. And we're going to be showing this in the demo too. So when using Sagemaker, you have a few options on where you're going to get your algorithms. The most common option, especially for people who don't have a great deal of equity in algorithms that they've already developed or paid to be developed, they'll go right into the built-in algorithms on Sagemaker. These algorithms are built to be super performant. They're optimized for petabyte scale data sets. They're already built in, and you don't really have to do a whole lot. You just kind of learn, what they do. You learn what the hyperparameters are, and you just sort of use the Sagemaker process as it's meant to be used. Another thing you can do is you could write your own custom script using a supported framework, which would be something like scikit-learn, TensorFlow, PyTorch, MXNet for deep learning. You could write your own algorithm from scratch if you have the ability to, and you're an expert in math and you want to just write your own algorithms, and you have something that you already developed. That's fine. You put it right into a Docker container, run that in Sagemaker. And then the final option would be to go into the AWS Marketplace and purchase an algorithm that somebody else has already built. So maybe somebody else wrote their own algorithm. It works excellently. You can go purchase it from them. And in turn, if you write algorithms and you want to make some money because they run really well, then you could host them in the AWS Marketplace and then make some money that way. So those are the 4 ways that people obtain algorithms for use in Sagemaker. There's another poll. I know this is going quite fast, so please do not be shy about questions.
Now, this is more a question around in which manner does your organization leverage machine learning algorithms? So I'll share the results in 20, 30 seconds. Seeing some answers come in. All right, great results. Mostly open source. Yeah,
that's pretty common. The scikit-learns, the TensorFlows, the MXNets of the machine learning world. Those are great ways to get started for sure. They may not be the easiest ways though. So for the people out there who have experience using the frameworks and all the open source stuff, all of these algorithm types are probably very familiar. XGBoost, PCAs, LDA. This is just these are the core algorithms that are built into Sagemaker. They still work mostly the way you'd expect them to from any other framework, like PCA for feature selection, K-means for clustering. You have forecasting using what's called linear learner, which is just a regression model. Pretty much. If anybody who wants to ask algorithm-specific questions, I'd love to talk about this stuff. Please feel free to, especially email me. We'd happy to have conversations. I don't want to go too deep into any given algorithm though. Okay, so one of the coolest parts about Sagemaker is the automatic hyperparameter tuning. Anybody who's developed models using one of the traditional frameworks knows that it's a try and try again process. You build a model, you train it, you evaluate it using one of several methods, you see how it works, then you ultimately end up doing a lot of tuning manually, then trying again until eventually you come up with a model that is acceptable to you. What Sagemaker does is it runs n number of training jobs, it tunes the hyperparameters automatically, and it tries to optimize automatically, picking the best model at the end. So this saves a lot of time that would otherwise be spent doing manual evaluation on your model sets. It's probably one of the coolest things in Sagemaker, just because I've had experience with training models and over and over again, spending hours, especially waiting for them to train. And the cool thing is with Sagemaker, you can have as much compute essentially as you need. And so if you want to run multiple models at the same time, you're not, limited to how much compute you could use. Does the selector allow? It looks like there's a question. The top models. Okay, so Greg is asking whether or not you can, so I believe the question is, once your models are getting better and better, can you just kind of knock off the ones that aren't performing so well and then train on, try to tune those ones individually? Is that correct, Greg? Basically. That's a great, I don't believe that's actually possible right now. I think it's kind of a, you could get the best parameters and then sort of maybe kick it off with those ones and then do it again. I don't believe it's doing any kind of recursive or reclusive mutations or anything like that at this point. But you know what? I've never actually tested that myself. So let me, after this, I'll get your email. I'd love to talk about that. One more poll. I wrote this question out of experience, having insufficient compute power to do a lot of the things I was trying to do, especially when I was in school with this stuff. You go into a seminar or a class and they teach you how to do all this super powerful stuff with these algorithms, and you go to try to actually do them yourself and your computer can't handle it. Okay, a mixture of, nobody disagrees. Oh, okay. I spoke too soon. Somebody disagrees.
I'll give it 5 more seconds till we hit a minute.
All right, only one person disagrees, Courtney. The rest is,
Here
okay.
we go, sharing the results.
That's pretty good. That's pretty good. Okay, fair enough. So what this leads into is, I don't want to spend a terrible amount of time on this because it's pretty simple, is that whatever you're trying to do in AWS, there's essentially a EC2 instance type that's meant for that task. So notebooks typically use T3 or M5s, while when you're doing a AIML training, you want something a little bit more powerful, like a GPU type instance. And when you are doing inference models, which we'll get into next, you're probably going to want a more compute intensive type of instance to be able to serve those predictions back to your application as fast as possible. Okay, so the final piece is all about inference. And so once you've cleaned your data, you've trained your models, you're happy with your models, now you want to actually be able to deploy those models into a production environment so your application or whatever it is can use these models to predict things about your data or more real-time application data. There are multiple ways to run your inference models on AWS. So we're going to go sort of piece by piece and just talk about these different ways to really utilize these models to give business value. So in certain circumstances, you don't necessarily need to integrate these models into a real-time application. You might just want to run a daily, a weekly, or a monthly batch over your data and get a bunch of predictions back all at one time. It makes sense to do that because you want to save on compute power. You don't want to have this thing running all the time. That's what batch transform is for. So rather than having a inference server up 24/7 because it's supporting an application, you can basically just spin up a server, do your whole batch, and then spin it right back down. You don't have to manage any infrastructure. It essentially will spit the results right back into S3, and then whatever this is typically for more analytical purposes, this batch type of prediction modeling. So yeah, and then when you do have an application that is relying on this on your model, maybe it's an app that takes in some review off a website and you want to send it up to AWS Sagemaker and determine if it's a positive or negative review. You're going to use the hosting service available on Sagemaker. Essentially how this works is just an HTTPS endpoint. It works like an API. You shoot up can you talk about real-time data versus historical data in this context? Yeah, so when I say batch, when we talk about batch on SageMaker, it's because you don't necessarily need that response right then. You're fine with having that data, that raw data sitting in S3 for a day or so, and then maybe your analytics team wants to run some queries over that data, but they really need that prediction to really get what they want out of their analysis. That's when you're going to do sort of predictive modeling over historical data, because nobody really needs that response the second that it happened, the second that the raw data was produced, in a sense. Real-time predictions are really there to support applications where a response is needed in real time. So let's say, the application does something with images, and that app needs to know what's in that image real time. So it needs to know if there's people in the image, if there's a tree in the image, if there's pets in the image. You send that image up to, a model that you've built in Sagemaker, you send it up to recognition, then you get your response, and then that sort of determines how your application runs. That's the difference between real time and historical in this context. Does that answer your question, Scott? Okay, so back to the hosting services of Sagemaker. Like I said, HTTPS endpoints, elastic configuration. So these things scale with traffic. So let's say you have one server up, it's getting absolutely nailed because of whatever reason. It will scale that compute power up so you don't have downtime. Similarly, multi-availability zone support. So if something happens to a data center in one part of Virginia or North Virginia, and gets wiped out by a natural disaster, your inference models are still going to run because they're multi-availability zone. Very fast, sub-second latency, but the difference between this and batch is you have a persistent deployment, which essentially means that the server stays there indefinitely until no longer needed. So if you take it down, your application essentially isn't going to function in this aspect. So elastic inference is very similar to the hosted method that we just talked about in the last slide. The only difference is it allows you to use a part of a GPU instance without having to actually have a GPU instance. It's really interesting. So you can use fractional GPUs, which just speed up the CPU instance that you already have and just make your instances run a lot faster. So what this does is it speeds up your inferences. But the thing is that these elastic inference is not supported for everything on SageMaker. It really is supported by specific frameworks, some of which people are probably familiar with, TensorFlow, MXNet for deep learning type of things. And there are other frameworks, but not everything can be used with elastic inference, unfortunately. Okay, so sometimes you have a model that you don't necessarily want to run directly in SageMaker. Maybe you want to run on an EC2, a traditional one, or maybe you want to run on an IoT device, more likely. This is where Amazon Neo comes into place. You can train your model once and deploy anywhere. It basically compiles down to a smaller size. It increases the performance that it would have otherwise been had you just tried to, plop the model on the way that it was. And you can run this on all kinds of devices, which really gives a lot of opportunity because IoT is getting bigger and bigger. There's more and more devices as time goes on. So Neo is a really great tool because it's looking forward into the, how things are going with IoT. And I think this is just going to be an absolute game changer. So that's exciting. And yep. And then finally, if we talked a little bit about this before, the AWS Marketplace, where you can basically, you take your train model, you train it, you're happy with it, it's a great model. You put it into a Docker container, and then you can sell that on AWS Marketplace just so other people can utilize your already trained model. It's kind of like making your own tier 1 AI service on the ML stack. It's like if you made your own version of like a recognition or a text extract or a forecast or something like that, and you can actually get paid for other people to use your pre-built Docker image. And there are plenty of them on there. So oftentimes A good thing to do is first look at the suite of out-of-the-box services that AWS provides, and then just take a quick look over the AWS Marketplace and see if somebody else has already done something that they're offering in the marketplace that accomplishes exactly your goal, just to save time. Because the ultimate, the reason why AWS and machine learning and Sagemaker have gotten so popular is because it really makes the whole machine learning process a lot easier for businesses. And that's the only reason why more businesses haven't already gotten onto this ship. So it's a really powerful thing. So these are sort of Deep Lens and Deep Racer are sort of anomalies, I would say, on this list of inference hosting components. Deep Lens, basically, it's a camera attached to a computer that can do things. You feed it an algorithm, a deep learning algorithm. It can recognize faces and things like that. It can do image recognition, sentiment analysis over people's faces. Like, for example, if you set up a Deep Lens at like a conference, it can look into the crowd and analyze, are people happy? Are people, sad, things like that, angry, that sort of thing. And it's a really good learning tool just to get your hands on deep learning and computer vision. But it's also got a pretty cool amount of possibilities with business use cases. It's not solely educational. If you wanted to maybe put a Deep Lens, say outside your, the doors of your business, and you can, say it could read somebody walking up, read their face and say, can they come in or not? Because their face is recognized. There are actually business use cases. On the other hand, Deep Racer, it's really a educational tool. What you do is essentially you train models using AWS. You upload them to this little car, and then based on your model, it'll try to autonomously drive. It's pretty cool. It's really cool to watch, actually. Amazon essentially has competitions with this thing where they build the track. All kinds of teams build them, train their models. They upload them, and they see how well they do going around the track. We've actually done one of those at Eagle Dream ourselves and had a really fun time with it. But that is solely, I would say, an educational tool, a fun tool. There's not going to be a whole lot of business use cases for Deep Racer, but nevertheless, it's fun. These are just some of the 10,000, I'm sure way more since this was made, plus customers using Sagemaker. It's becoming incredibly popular just because of how seamless it is to use and maintain, especially. So if that's not enough evidence, I don't know what is, because these are a lot of big organizations using it. And like I said before, I know this is this deck is particularly high level on this stuff. So if anybody would like to reach out to me or ask questions in the Q&A or now, or I'd love to, even show in the council what this stuff looks like, just so everybody feels like they have a good understanding of what this thing can do. Okay, no one said I still think it's too complicated. That's good. It's a win.
Yeah, I think we're going to end up with people going through the live, then probably circling back through the recording in the deck. And you're definitely encouraged. If you have questions when you do the circle back or when you actually start building something, let us know. We'll answer questions. Contact information will be provided when we share everything. So yeah, you get a couple weeks down the road and you're in the middle of something and you just have a question on what you're working on. We're more than happy to answer that.
Just a AWS Machine Learning University. That's just a resource for getting hands-on with some of this stuff.